Hello everyone, welcome to Size Up Academy. Here we are empowering the education through digital content. So this is me Mallikarjuna. Today we are going to see the basics of MTI radar systems. MTI is meant for moving target indicator. So without further delay, let's get started. So these are all our today's session outlines. So we are going to see the basics of MTI radar systems, and then we'll see the block diagram of MTI radar systems. Then we'll go ahead with the working principles of MTI radar systems. Then we'll see what are delay line cancellers and how we can represent them in diagrammatic format. So let's start with the basics of MTI radar systems. So in MTI radar system, we'll be having a continuous wave generator which is generating continuous pulses into airspace which is getting reflected by the target. So this is the basics of MTI radar system, where this continuous pulses is going to be generated, and based on the target movement, whether it's towards the antenna or it's away from the antenna, based on that we are going to calculate the velocity of the object. So that's the ultimate aim of using moving target indicator, as the name suggests. So now we'll see the block diagram of MTI radar system, basic block diagram of it. So this is the basic block diagram of MTI radar systems, where we are splitting this into two sections, one for transmitter section and one for receiver section. So the continuous wave oscillator is going to be a common section for both transmitter and receiver. So the continuous wave oscillator is going to generate continuous sine waves or cosine waves, and the pulse modulator is going to generate pulses similar to this. So post that, the generated pulses are going to be amplified, then it's going to be transmitted into the airspace. So on the other hand, when we receive the reflected signal from the target, in that case the receiver section is going to have an antenna which will be responsible for reception of the reflected pulses. So those pulses are going to be given to the low noise amplifier, which helps us to get the radio frequency of the incoming signal, and then it will be given to the mixer for determining the intermediate frequency. So that intermediate frequency helps us to identify the velocity of the object based on its movement away from the antenna or towards the antenna. So this is the basic block diagram of MTI radar systems. So let's move ahead with the working principle of it. So from MTI radar system, let's say we are generating a continuous pulses into airspace, and suppose if our target is moving away from the antenna, so let's assume that we are transmitting frequency f0. Then if our target is going away from the antenna, then the reflected pulses are going to have a frequency called f0 minus fd. Here in our case, the fd is going to be the drift frequency. So the drift frequency is because of the velocity of the object, the drift happening due to the target movement. So that is what it's meant by. So on the other hand, when the target is moving towards the antenna, then the frequency is going to be added with the drift frequency. So the combined frequency that we will be receiving at the reception antenna is going to be f0 plus fd. So this is the one, and the range is going to be r in our case. So the pulse is going to travel 2 times of r. So the total distance traveled by the pulse is going to be 2 times of r. So this is the basic principles how the MTI radar systems works. So let's see what are delay line cancellers and where we can use them in MTI radar systems. So let's go ahead with the basics. So delay line cancellers are basically used in MTI radar systems. So these are actually filters which helps us to eliminate the low frequency clutters in the received signal. So because of this particular property, we can able to get high resolution of the specific object identification. So these are all some basic info about delay line canceller. Now we'll see a simple diagram to understand how delay line cancellers works. So this is our basic block diagram of delay line canceller. It is as simple as that. Like we'll be giving the input to the delay, which will be calculating the delay period based on the pulse repetition time period. Then the input will be given to the subtractor, and also the delayed signal will be given to the subtractor. So the resultant is going to be our drift frequency. So this drift frequency is going to help us identify the velocity of the object. So I hope you understand this concept. So thank you for watching this video, guys. So do let us know if you have any questions in the comment section. So all the class notes with examples some solved are uploaded in the cloud, and we have shared the link in the description. Thank you for watching this video, guys. See you in the next one.